A very good evening, ladies and gentlemen. I am Naveen Labana and I welcome you all to our new episode of Live with Agrosa. To get bigger results in life, we must not rely on big changes. I repeat, to get bigger results in life, we must not rely on big changes. Even a small change can make a big difference. Little by little, a little becomes a lot. With this thought, today we have a very special guest and our first international guest, Dr. Aziz Nurbekov. He is a senior agronomist with more than 28 years of experience in sustainable land management, conservation of agriculture, plant breeding, seed production and range management. Currently, he is a professor at Tashkent State Agrarian University and an FAO consultant on agronomy. Before I turn to Dr. Aziz for questions and answers, I would like to request our audience and viewers, if you have any questions, any doubt, you can always write your doubt in the comment box with your phone number, or you can message us with your phone number. We will try to give you the best possible solution. A very warm welcome to you, Dr. Aziz.
Thank you.
Right, sir. So let me throw my first question to you, sir. You have done great work on conservation of agriculture. So my first question to you is related to conservation of agriculture itself. We would like to understand what is conservation of agriculture and also how it is beneficial for a country like India. So.
Thank you for this question, and this is very good question because conservation agriculture is now becoming more and more worldwide. Conservation agriculture is one of the most promising land use options that have been developed in our times.
Right.
It is more than an approach than a technology. As it consists in varying array of techniques that aim minimizing soil disturbance,
Okay.
soil water and nutrition losses,
Right.
and that preserve many of the ecological functions a natural soil has to offer in a natural ecosystems.
Okay.
Conservation agriculture has many proven benefits, and it covers millions of hectares in South America and North America,
Right.
and as well as in the Gangetic plains of India.
Correct.
Conservation agriculture has three main principles.
Right.
First principle is no-till or minimum soil disturbance.
Okay.
Second principle is crop residue retention or cover crop, and soil should be covered by plant residuals. The third principle is crop rotation or crop diversification.
Okay.
If all three principles are coming together, only in that case we can say this is the conservation agriculture practices. For your information, I can say now that worldwide adoption of conservation agriculture is about 190 million hectare. So it is more than 13% of arable land worldwide. So it means the conservation agriculture is becoming more and more adopted by many countries, especially when we talk about India. Conservation agriculture already adopted in India, and so more than millions of hectares are adopted by this conservation agriculture in India. So mostly in wheat, rice rotation system, mostly in Punjab area of India,
Right.
Conservation agriculture is adopted. So that's so we can also say that this is good for Indian farmers. As conservation agriculture is benefits from conservation agriculture are as follows. First, so we reduce soil erosion.
Right.
So we reduce soil degradation or land degradation.
Right.
So through improving soil fertility and soil moisture under the conservation agriculture much more higher than conventional agriculture.
Right.
And also we should also say that under the for Indian conditions, it is very important to use water saving technologies which conservation agriculture can address.
Right.
So a lot of farmers in India using this groundwater,
Yes.
using groundwater, pumping the water from the ground.
Yes.
So in this case, so we should also think about how to save water. To save water, we always use different techniques. Conservation agriculture addresses those techniques because under the conservation agriculture, I said already, so we reduce soil evaporation, we keep soil moisture in the soil.
Right.
So that's why in this case we will use better water efficiency. So in this case I can say that this is the right technology for Indian farmers to adopt conservation agriculture practices.
Great, great, sir. What a great information, in fact, for our viewers. I'm sure that this kind of setup, if we use this system, kind of all the three important points which you have already spoken about, the disturbance of soil, permanent soil cover you spoke about, and you also spoke about crop rotation. Beautifully said that how it will save the moisture content of the soil and how it can stop the soil erosion. And India as a whole definitely has that kind of problem, and by implementing conservation of agriculture, I'm sure most of the problem would be sorted. Very well said, sir. Let me get to the second question. You have done a lot of work on seed multiplication systems, sir. And there have been a time, in fact, when the discussion on seed multiplication system have been kind of the topmost priority of all the top scientists related to the field. We want to understand from you, sir, what is this seed multiplication system actually? And also we like to understand how does it give that edge to the agriculture sector?
Thank you very much. This is a very good question. Because seed is the most important input for accelerating agricultural growth.
Right.
And also, seed is a primary input for agricultural, commercial or subsistence. Because why it is primary input?
Right.
So if you have land, if you have land, if you have agricultural inputs, fertilizer, or this pesticides, herbicides, everything you have. But if you don't have seed, so you cannot start agriculture. So in this point, I can say that seed is the primary input in agriculture to get a good yield, because through good seed you can get a good crop, and also benefit from this while growing this crop.
Right.
So therefore, the seed production of high-yielding varieties is important to make available quality seed for increasing agricultural production.
Okay.
In this case, the main objective of seed production is rapid multiplication of newly released or commercially available varieties by maintaining the varietal identity and genetic purity that represent the plant population created through breeding, characterized by certain heritable, morphological and biological and agronomic traits.
Okay.
So when it comes to rapid seed multiplication, I can say one example from India.
Right.
So everybody knows who involved in agriculture. In the 1960s, India, Pakistan, and these South Asian countries made a green revolution.
Yes.
The green revolution made only because of good varieties, certain good varieties from Mexico. So in CIMMYT, they developed several high-yielding wheat varieties, and those varieties imported to India, and only through the rapid multiplication of seeds, the Indian farmers started. They increased the yield almost double.
Right.
So you can, everybody can find this information from the internet, but here I can say that only thanks to the government of India that happened, because government of India took very good decision that time for rapid seed multiplication of those varieties. I can say some varieties, Lerma Rojo 64, so Siete Cerros, and Sonora 64, those varieties imported from Mexico to India, and thanks to these varieties, wheat yield in India almost doubled that time. So and also we can also say that the state of Punjab led India's Great Revolution and earned the distinction of being countries with basket. And when we say that about seed multiplication, and also there is several steps. So we can say that what kind of steps we do have.
Right.
First step, we have a nucleus seed. The second and the breeder seed. The third is pre-basic seed. Fourth is basic seed, and fifth is certified one, and sixth is certified two. So all these 6 steps should be passed during the seed multiplication.
Right.
So if we follow these steps, then we can have a good seed, good quality of seed, and also we will have a good crop yield from any crop. This is not only related to wheat, for any crops.
For other crops as well. Fantastic, sir. Great. If I just speak in a layman's language, I believe you said a very appropriate definition. Rapid multiplication. It means there is no hybrid formation. It is a rapid multiplication of the same seed, right? So you're trying to get the best
Yes,
seed out of the seed, right? So very truly said, sir. And you rightly indicated how the Green Revolution happened in India in 1960s. And thanks to the government of India at the time taking all those steps, you rightly gave the name of those wheat seeds which we brought from Mexico. And rightly said that how the Indian agriculture system changed after that one step. The Punjab area produced, I mean, it was a turnover kind of, bombastic production in Punjab and Haryana and in Madhya Pradesh and other states. And we are still reaping the fruits of those steps which were taken at the time. Great, sir. Fantastic. Let me throw the next question at you, sir. You have been doing a lot of work on salinity of soil, sir. And my next question is related to the salt stress. So salinity, even in India as well as in other countries across the world, has been a very big silent problem, I would say. So we want to understand, Dr. Aziz, from you that how salt stress affects agriculture system as a whole, and especially in a growth rate of plant, especially a plant sapling.
Thank you. This is also a very good question. Why? In the globe we have about 300 million hectares of irrigated land.
Right.
And out of these, almost 60 million hectares are salinized or affected by salinity.
Right.
So, yes, or suffering from salinity. Salinity is a major constraint for crop production, especially in arid and semi-arid regions of the world.
Right.
And where low precipitation, high surface evaporation, irrigation with saline water, rising water tables, and poor irrigation practices generally increase the levels of soluble salt.
Right.
And salinity problem are based from accumulation of soluble salts in the plant root zone, including irrigation water.
Oh.
In sodic soils, high level of exchangeable sodium, sodium, cause the individual sand, silt, and clay particles to be separated and not clumped together into larger particles or the salt before any effect are seen.
Right.
Yeah. So in this case, salt through the salt plant can be damaged entirely. Sometimes 100% plant can be damaged, and then you cannot get any yield out of this crop. So in this case, we need a salt-resistant crop. Salt tolerant crops we don't need, and there is a table. So we can you can show this table. In that table, we can say that there are several field crops which are resistant to certain amount of soil. So this, for example, if we can say DSM, if DSM is about 16 DSM, in this case there is no any agricultural crops, no any agricultural crop can survive, because all the agricultural crop will be damaged or salt. But when we talk about other DSMs, for example, if the salt DSM is about 8, in this case, there are agricultural crops. We can say that winter wheat, barley, spring oats, flax, these crops can survive and you can get yield from this. And also out of forage crops, we can say that sweet clover, meliotis, or sorghum, permillet, and fodder beans. These crops also widely grown in India because there are a lot of sorghum and permillet production in India. By area, India is the number one by sorghum area.
Yes.
By production, also India also in the one of the world in the higher position in the by production of sorghum in India.
Right.
So that's why in this case I can say also that so we can refer to conservation agriculture. As you know, this there is a second principle covering cover crops or crop residue retention.
Yes.
So through crop residue retention, we can fight against too salt in the irrigated conditions.
Right.
How we can fight against? So there is a very easy way. We can say that so just you keep this crop residue in the upper layer of soil.
Right.
In the upper layer of soil, you can keep this the crop residue,
right.
And then you can decrease evaporation from the soil.
Yes.
So please note that salt always coming through evaporation to the soil.
Oh.
This is the main way how our soil become salty in the upper layer, and then only in this case we can also say this is the seepage salinity. Seepage salinity stops this osmotic in the plant, so that the plant cannot be survive to salinity. But through using crop residue, and we can fight against soil salinity very easily, because we can just keep this in that in the upper layer soil. So we cover with crop residue, and we can keep the soil moisture in the upper layer soil. Because of this, the salt from the bottom, they cannot this evaporate because of this soil moisture in the upper layer soil. Right. So because of this, so we can fight against. And also in India also you can use this kind of how do you call this agri-techniques to fight against soil salinity. Not only growing this salt tolerant crops, but also through the techniques. And there are also other techniques in the fight against salinity, salt leaching. But salt leaching, we cannot recommend for Indian farmers, because limited water. In that case, please use only this crop residue retention, and also this through planting or sowing salt resistant or salt tolerant crops or plants.
Great, fantastic, sir, fantastic. In fact, this was very kind of important message for not even for the farmers, but even for the government, I believe. Of course, you are very right, sir. In fact, in India, if I talk about, see, we have a huge coastal line, right? And it is very evident, being a coastal area, the salinity of the soil is quite high. And also, there are certain areas in India which is very dry. Due to being a dry region, the salinity of that area or the soil also increases. You have given fantastic two methods, and third you have denied, but of course, I mean, that is also important method. You talked about salt leaching, but I believe very rightly said, sir, that salt resistant crops which you named, which my audience and the viewers would also be seeing on the screen, they are fantastic method of using, rather getting the best of the soil where the salinity is high or moderate or low, as well as the method which you talked about, crop residual retention. Fantastic, sir. I mean, I believe that method already have been tested worldwide in other countries as well, and I think that I'm sure that certain region and certain educated farmers in India might be implementing that method in India. It's a fantastic method. You should always keep the residual of the crop there in the fields, so that the moisture content of the soil is not escaped. It is the soil retain the moisture content. Great, sir. Great methods suggested by you. Now let me come to you with my next question, sir. It is regarding the climatic condition. Of course, across the globe we see, I mean, every country does not have one climatic condition. I mean, generally they have various climatic conditions. So my question to you, sir, that how agriculture system of any country could adopt and adapt to the best solutions and ever-changing climatic conditions.
Thank you very much. Of course, the issue of climate change is now becoming more and more problem. Not only one country, worldwide, I can say.
Yes.
So in this case, the scientists are already started work how we can do our agriculture in changing climate.
Right.
So when I can say from Uzbekistan side, in Uzbekistan we have also developed several scenarios for climate condition in the future, and many climate scenarios which we developed here is that most of the scenarios in Uzbekistan there will be less rain or less water. So that's why so our research now mostly focused to drought tolerant crops, and to use water saving technologies in the future. Not only in the future, but from now we should start this kind of technologies or techniques in Uzbek conditions, because of this now we are working on drought tolerant crops, and not only drought tolerant crops, we are also working with crop rotation system, which can give sustainable yield over the years if we do have a drought. And also we changing water regime or irrigation practices here. For example, if we have now this cotton and wheat rotation system in Uzbekistan. In this case, sometimes while watering cotton, the wheat will not require water.
Right.
In this case, so we should change the system from cotton to other crops, not wheat.
Okay.
Other crops, because through this we can save water, and also we can use water efficiently.
Right.
So these kind of practices are we are now testing, and now through this we can say that if real climate change happens, then we will be ready to work in those conditions also.
Great, sir. Fantastic, fantastic. In fact, you have nicely given the example of Uzbekistan. And even if I talk about India, I believe the climatic conditions sometimes, even in India, are very, very harsh. If I talk about the water level in India, in spite of all those rivers are going down. And even I believe that the practices which you rightly mentioned of selective crop method or drought tolerant crops which you talked about are very apt for countries like India and even countries like African countries where there is a lot of problem of water table and irrigation. Nicely said, sir. You have also given a very nice kind of, though it is very evident method and kind of everybody knows about it, crop rotation, but I believe nobody practices it anymore. So it is very important to do a regular practice of crop rotation that also helps in fighting the climatic conditions. Nicely said, sir. Great. I'm sure that my viewers, audience are going to treasure this kind of information. I want to ask you, I believe you have already been a user of AgroSha machineries, especially for your seed testing and activities related to seed. There was a time far back, I believe you have used AgroSha machines as well. So you have been using machines. I just want to understand your kind of, you can say it kind of feedback, or what do you say about the machines which you have used of AgroSha, especially in your country?
This question is very good. Because this is a good memory for me. So because 16 years ago, when I started working in ICARDA, in International Center Agriculture Research in the dry areas. So that time I was working with conservation agriculture project. And also at the same time, I started work with seed project. Under the seed project, we had a clear work plan to buy a seed conditioning plant for Uzbek farmers. So that in that case, we announced a tender. Then when we checked all the vendors of this tender, and then we decided that to buy seed conditioning plant from Agroso, because the Agroso seed conditioning plant was much more cheaper than European or the US seed conditioning plants, but when it comes to quality was at the same level with European standards. So that's why then we decided to procure this seed conditioning plant from Agroso. So it is for me very to say that so these conditioning plants are still working.
Oh, really? Wow.
Yes, still working.
Wow.
So because almost 14 years, but still this conditioning plant is working. And then I can also share with you some these pictures of these plants, old one and new one.
Wow.
But So why this seed conditioning plant is still working? Because of quality, and also because of this good for Uzbek conditions.
Right.
And also this plant can work in the field,
Yes.
not only in the one place in the shadow. Just you can install once and then you don't move to anywhere. But this plant, we can move from one place to another place.
Okay,
Farmers are using very easy to use.
Right.
And also, so this plant can work with electricity and also with fuel.
Oh.
So if there is no electricity, you can just use fuel, and then you can condition your seed. It is easily. So that's why from this taking this opportunity, I can say this manager of this agroso company, Sanjeev Sagar, Mr. Sanjeev Sagar, and to his team for this very good seed conditioning plant which they provided to us. And now also I can say our appreciations from our farmers to agroso, that so they are still using this seed conditioning plant. And if there is something for I can say that for the European type of this kind of plants, or the seed conditioning plant, so you can have your spare parts only from Europe. So, but with Indian, with agroso, the seed conditioning plant, if something is broken, and then you can easily find these from the local market.
Oh, great.
Yeah.
Thank you, Dr. Aziz. I mean, your word of appreciation means a lot to us, and we are really very glad and happy, that you took that machine to your country and used it to the best abilities. And I'm really very happy to hear this, that you are running that plant since last 14 years and it's still working. It's still working. Fantastic.
Yes.
So, I mean, we do not compromise with the quality, that is for sure, which you have already appreciated, and your words means a lot to us.
Yes.
Sir, Dr. Aziz, I really thank you very much for your precious time which you have given to us, and to our viewers and to our audience. The kind of questions which you have answered, it is going to be in the knowledge bank of AgroSA. My audience and viewers can always go there and view it. Fantastic, enormous, treacherous knowledge you have given today, sir. Thank you so much for your time. And I would also like to thank my audience and viewers. I'll repeat that if you have any kind of more doubt and you want to directly reach out to Dr. Aziz, you can message us with your number or email ID. We will share your information with Dr. Aziz, and I'm sure that Dr. Aziz would be very happy to answer your questions. Thank you. Dr. Aziz, would you like to say some last words, please?
Yes, you are absolutely right. So if our farmers send any question, so I am very happy to answer. And also, so I would like also thank to you to giving me this opportunity to talk about my experience, a little experience on conservation agriculture, on seed multiplication, or about salinity, and also my experience with working agroso equipment. So this is just, it was very, I think that useful for me also to get in touch with you in these very important questions you raised. These questions are not only related to Indian farmers, these questions are related to all worldwide farmers. including Uzbekistan. So that's why, in that case, my thank to you for giving me opportunity this once again.
Right. It was our opportunity, to be honest, sir. And I'm sure you rightly said that the information is available in the, as I said, in the knowledge bank, and definitely anybody from anywhere in the world across the globe can access to this, to your interview, to your answers, and get the required solutions. Great, sir.
Yeah.
Thank you. Thank you so much. Thank you once again.
You're welcome.
Pleasure.
You're welcome.